arithmetic sequences, finding a term or a general term, we'll call it. Quickly defined on the side here. Here's our general term equation. Here's the function notation of it, and here's our definitions on the right. We've gone through these before, right? So here's our question. Our question gives you the 7th term, which is 53, the 11th term, which is 97, and it says find the 100th term. Okay, well, we have a formula, and we have some variables, so let's start plugging them in and see how many are left over for us to find. So I'm going to redefine this. That's also known as T7, and this is also known as T11, right? And they want us to find T100. Oh my gosh, why is it writing like that? There you go. Okay, so that's a little different. So let's take our general term. We know that T at n, or T at 7, is equal to 53. So that's the beginning of the formula. So 53 is equal to, we don't have an A term. We do have an N term. N, in this case, is 7. It's the 7th term, right? So N minus 1. And we don't have a common difference. So right now we're looking at two missing variables. To solve two missing variables, you need two related equations. If there's only one variable, you just need one equation. Right now we only have one equation, but there's a whole second one here. So let's do the exact same thing. The 11th term is 97. Okay, so 97 is equal to, A is also unknown again. Our n value, I would just realize I didn't even write the last n value. What the? I don't know what's going on there. No idea. Okay, I'm just going to write over that. Thank you. 7. Here it's 11 minus 1. And D is unknown. Okay, so two common unknowns. Two different equations? Great. We can actually work with this. This is isolating equations, or like, think of it like finding the intersection of two linear equations. So in order to do that, we need to set them equal to one of the variables. Quickly looking at it, I think it might be fastest to set it equal to A. I'll just move 53 over, and then A to the other side. Same thing with 97, and then we'll have two equations that are set equal to A. Okay, and in fact, we only have to do it for one of them. Let's call this equation 1 and equation 2. So I'll work with equation 1 to start. Equation 1 is 53. Whoops. Okay, 53 is equal to, I'll just go write everything in black now to speed it up. A plus 7 minus 1, we actually know what that is. That's 6 times D. We're going to isolate for A. So let's move 53 over. It's the same as subtracting 53 one side, and let's move A to the other. Let's same like adding. So when A comes over, it technically becomes negative A is equal to negative 53 plus 6D. Are you okay with that? Yep. And we usually want to work with a positive version of something. So think of it like you're multiplying this entire equation by negative 1, and it's just going to flip all the signs and make this A. So this will become A. Positive 53 minus 6D. Great. We have what A is equal to. So we can use substitution. We can just plug that into A of the second equation. Okay, so let's take equation number 2. 97 is equal to, well, what is our A? A is 53 minus 6D. And then the rest of the equation, plus 11 minus 1, which is 10, times D. Now, what have we done? We've set up, and actually I should color it just a little different for you. There's only one variable left. If you take a look, just D, and we have values. So one variable, one equation, wonderful. We can actually solve for what D is. So let's kind of go through this process here. And sorry, there's another D in here, but it's still the same thing. It's still just one variable. So, 97. We can drop the brackets, and we can make that just one term. So 53 minus 6D plus 10D. Okay, 6D and 10D are common terms.
So it'll be 4D.
Perfect. 53, positive 4D, 97. Bring 53 to the other side. 97 minus 53 is equal to, I don't know why that's happening. I guess my pen is running out. 4D. There we go. 97 minus 50, 2 sevens, that's 90, 60, 30, 74? No, 44. That's right. 44, 4D.
Divide by 11.
Perfect. We divide by 4, you could say. 11 is equal D. Wonderful. All we've done is find D. Haven't even found A yet. But because we have D, we can just take one of the original equations and
Substitute.
exactly. So I'm going to open another page here so we can move it over. Let's see if we remember all of our stuff. I remember 53 was the 7th term. It's equal to A plus 7 minus 1 times D. And what did we say D was? 11? Perfect. So we take this information. Let's isolate for A. So 53 is equal to A plus 6 times 11.
66.
Perfect. Plus 66. We move it to the other side. 53 minus 66 is equal to A. A will give us 7 and 6 is 13. Minus 13, I believe. So we have an A term. A term of negative 13. So we have an A term, negative 13. We have a D term. They want us to find the 100th, or T at 100, right? Let's build the general term from the information we have, and then just plug in for 100. So remember, general term is T at N is equal to A. A is negative 13, perfect, plus N minus 1 times common difference, which is 11. Great. They want us to find T at 100, so we're going to say T at 100 is equal to negative 13 plus 100 minus 1 times 11. Okay. T at 100 will equal negative 13. 99 times 11. Let's do it over here. 99 and 11. That's going to be 9, 9, 9, 9, 9. 1089. That's my guess, okay? Minus 13 plus 1089. T at 100. 1089 minus 13, I think it's going to be 1076. T at 100. Does that seem right? Is that what they got over there? We should check our answer.
Yeah, 176.
Was it? Okay. We checked on a book. We got the right answer. And we could have done the same thing with function notation. We just would have had to find out what their B value is. But it's the same concept, okay? All right.